Alrighty. Welcome. I'm Wes. I'm going to be doing some live coding today. My goal is to add some connection time metadata into KumoMTA. For those that don't know, KumoMTA is a high-performance mail transfer agent designed for doing SMTP primarily for people that need to send at scale. Now, one of the things we also have to do is support incoming mail, and we have a bit of a feature gap today, and let me demonstrate by pulling up the docs. So in KumoMTA, we have a number of event handlers that trigger as mail comes into the system, and you can see here we've got one which corresponds to the EHLO phase of the SMTP, and this allows you to do some reception time validation. So what this does essentially is it parses the incoming message from the client side, and in this case EHLO passes in a domain parameter and passes it in so you can actually do something. So like in the example here, we're saying like if the domain is like from a fictional bad actor domain, then we'll reject it, and that's fine. But there's an issue here. I'll get to that in just a moment. If we look at another one of these events, we've got another one here for mail from, and this is for the mail from portion of the transaction, and here it gets passed in the sender. So this is very similar to the previous example, the main difference being the sender has like a domain and a local part or a full email address. And in both cases, the existing hooks, they allow you to operate on the data passed in by the client in that moment. But what they're missing is a way to pass information from one of those into the other, right? So, for example, you might want to, store some information that you've derived from the incoming connection state during EHLO, and decide to act on it a little bit later because maybe you don't have enough information to fully decide. So right now, there's not an API surface for you to be able to access that kind of information, and like a more concrete example of this is we have another one of these event handlers here for when authentication happens. So as you may or may not know, SMTP doesn't require authentication in order to pass mail, but a site may decide that authentication is required. So for example, if you are running a service with multiple different users or tenants, then presumably you're giving them each individual username and password credentials, but you don't want one of your tenants to be able to send as one of your other tenants, for example. So it's desirable to be able to say, when this tenant has authenticated, we will only allow relaying for them to the domains that we know are associated with that tenant. So we have a couple of hooks that are kind of close, but like there's a missing piece. So here's the authentication hook. And really all it's doing is allowing you to validate the user and password to see whether they know the credentials. But there's another reception time event called getListenerDomain, which allows you to see whether relaying is allowed either to or from a specific domain coming in through a specific listening endpoint. And in here, it would be desirable to know, like, is this incoming connection authenticated, and who are they authenticated as? Because that may actually like reframe the relaying decision that is made by this event handler. So that's the background on this. It may sound complicated, but it's not terribly complicated. So if we switch now to look at the code, I've pulled this up here. This is the SMTP server file. What this is showing here is this is the main state for the SMTP server. There's one of these structs that exists for every incoming connection that's made to the server. And you can see we've got some information that we would like to expose to Lua in here. So the authentication actually populates these authorization and authentication IDs from the authentication phase of SMTP, which is kind of what we want. You can also see we've got like the peer address and our local address in here as well, which is another piece of useful information. But what this doesn't have is like a way for you to sort of stick and stash like other state that you may have decided So like you may decide to pre-compute something and you just want to reference that later on and not have to like rederive that every single time that you need it. So that's a kind of a missing piece. There's another piece of information in here. There's this state parameter, which is an optional transaction state. And that corresponds to this struct down here. And this guy, when you initially connect to the server, it doesn't exist. It's set to none. So there is not one of them. There are none of them. When you issue a mail from, which is the start of a transaction according to the SMTP specification, we will create this transaction state and we'll keep track of like who the mail is claiming to be from, and we'll use it to accumulate the other state. So like as you add recipients to the incoming message, they get added in here. And there's also this metadata thing in here. And this is kind of what we want. This metadata is it's a type called a SERDI JSON value, and essentially it can be an arbitrary JSON object. And in fact, that's actually what it gets created as. It gets created as an empty JSON object. Now, the intent when I wrote this is that would actually accumulate the data and get assigned into the message metadata, which is a thing that we currently already have. On our message type, you can get and set arbitrary metadata. There's a few predefined fields that KumoMTA sets, and I'll show you some of these right now in here. So make this a bit larger so we can see what's going on. So you can see this bit of code actually happens right after we've accepted the data portion of the email, and we're assembling the actual final message before we stick it in our internal queues. So you can see it's like creating a message object, and it's populating some message metadata. So you can see that's actually copying those authorization authentication IDs that were in that main state that we looked at just a moment ago, and also setting some other things that are kind of handy, like the reception protocol and the address information. Now, this bit here, where we're creating the message, we actually cloned that state meta data, right? That thing that I pointed to earlier from the transaction state. So we use that, and then we extend that and add those additional fields. But what I kind of forgot when I implemented this piece of code right here is really these things should have gone into the transaction state's metadata, like during assembly of that transaction information, so that essentially this code here probably shouldn't be here in this logic. It should already have been factored into this guy, and then we would just like make a copy right here, and that would simplify that. So, there's a little bit of manipulation that we need to do in here, and also the transaction information only exists from mail from onwards. So, what I think I want to do is essentially move that metadata into the SMTP server state so that it lives there, and then move the population of this metadata stuff so it happens as soon as we know what this information is, and assign that into that shared global state. And that's kind of like part one. That kind of moves the data into the places where we need it. And then part two is like actually exposing that information into those Lua event hooks so that you can at least read it, but also ideally write to it. So we'll then be adding essentially like a little wrapping object that allows manipulating that and capturing the state and sticking it back into the server state again. So that's my game plan. I'm going to start with just moving it around, because that way the compiler will tell me if I've made a mistake during that part, and then we can sort of say like, okay, we've done that bit, and then we can move on to the sort of more interesting parts. So let's just start on that. I think what I'll do is I'll switch this to an up and down split, because I had to make my font larger to work on the screen better. So it's a bit more like comedy size on my screen, but probably very readable for you. So what I want to do is let's move metadata out of there and stick it over there. And then, because I am lazy, I'm just gonna let the compiler tell me where I need to move it. So it's saying, okay, we're missing a piece there, line 386. So let's hop over there. Right, yes. So it wants that I happen to know that it's initialized like this. So in the top portion of the screen here is where we used to populate it in the transaction state. That needs to be moved down to the bottom one. That's step one. Let's see what else it complains about. And it's saying you can't clone it from where we were cloning it because it doesn't live there anymore, right? So that's over here. So it doesn't belong in state anymore, right? So this, I think, is probably just going to be self instead of state. I have to sort of take that on a little bit of faith. If I scroll up a little bit, what you'll see is somewhere up here, state is this, it takes that state and carries on using it. We moved it out of that state, so it doesn't live there anymore. I think we can just clone the main part. There we go. Oh, that was easy. So that's good. Now the next thing is to populate these other pieces of information as soon as we have it. So let's start with that authentication or authorization. So these we're going to assign as soon as we know them. So this bit of code here, if I scroll up a little bit, this is handling the authentication stage. So there's a little bit involved. So we're matching on a parsed command where we figured out what the mechanism is, and there's just some stuff that is like keeping us compliant with the protocol and decoding the incoming information and so on and so on, and part of that is base64 decoding, and it's some guff really. So essentially the authentication is a base64 encoded 3 tuple of the authentication ID, the authorization ID, and the password, and that is represented on the wire or in the raw byte as like a null byte separated series of strings. So this logic is just parsing those apart. And you can see it's got the authentication stuff, blah 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 blah, doing some sanity checks, calls out to an authorization hook to see like, is that a valid user and password combination? And if all the conditions are true, then we stash what they are before we say authentication okay. So here is where we want to also put that information into that metadata context. So if I just go back to the other place where that lived, I'm just going to essentially move that code around a little bit so that we can stick it in here. But the difference really is we know that we've got it here. So we don't need to do this conditional stuff. However, it's not self-message because we don't have a message here. We just have like the JSON object. Well, this may actually get slightly fiddly. So I'm just going to do one of these to start with, and we'll sort of copy and paste the other one. So for the sake of consistency with naming, I'm going to use this same shorter name here. So it's consistent between looking in the message metadata and looking at the connection metadata. But essentially what we need to do is self meta, and logically we want to do something like set auth ID as a JSON string version of authc, right? Something like that. I suspect that won't compile because the object may not let it, but let's just see. Like maybe it will. Yeah, see, no, it doesn't like that. Now the reason for that is if we call up the docs SerDJSON, and if we look at the value type, because that metadata thing is a SerDJSON value, you can see a value can be any of these individual types. So it doesn't necessarily make sense for there to be a set method. You can see like down on the left here, like it, as the compiler suggested, there's a get method, and that does some magic that will work whether it's got the data inside is either a JSON array or a JSON object. It will sort of magically allow indexing in the correct way, but there isn't like a corresponding set. There's a get mut, which is the mutable version where you can update the existing value, but in our case we actually just want to edit the object. So what we really want to do is this as object mut here, so that we can look at it as an object, and what this returns is this map type where we then would be able to do a set operation on that. But we need to be careful because in theory may not be an object type. It may have a different type. In practice, we won't, but like the type system means we have to consider that that is a possibility and handle that. And in the example here, it's using unwrap. I'm not a fan of like an unexplained unwrap or an unannotated unwrap. I think I mentioned this on a previous video. I try to avoid those as much as possible, except when I don't. But this is a thing we want to be careful with here. So essentially what we need to do here is something like as, what was it? As object mute. Yes. And then what I normally do is something like okay or else, which is like a combinator type that is a combinator method that is associated with the option type that allows you to say we'll take the sum part of the value, assuming that that is okay, and otherwise if it's not okay because it's not that type, it's something else, then we'll run a different little bit of code in a lambda. That's what this double vertical bar is. And in there, what we're going to do is just generate like a generic error using the anyhow crate, which is just sort of like a very convenient way of working with errors without having to stress too much about the specific error types. So here I'm just going to do something like state should always be an object. Now, what I could have done instead of that is done expect with that same string inside, but the consequence of an expect failing will be that the panic will happen and the whole server will shut down, which is a bad thing to happen. So I'd rather just manifest as an error. It should never happen in practice, so it should be fine. This is just like a little bit of extra stuff to sort of feel good about ourselves, really. Then I'm going to use the question mark operator so that the error that it would generate gets propagated out. But otherwise, we end up hopefully with a map that we can just do that set operation on. So let's just see what the compiler says about that. No. What did I do wrong? Oh, it's probably insert, isn't it? Let's double check. Right. Yes, insert. There we go. I'm having trouble reading. Excellent. All right, so it's not set, it's insert. I just need to speak the right lingo. Cool. All right, so now it's just saying it wants that to be like a concrete string rather than a string reference, which is fine. So we'll make it one of those. And if we compile, that should be okay. Good. All right, so we know what the template looks like. I'm just going to do a format here. Make that look prettier. There we go. And then I'm just going to copy and paste that to do the other one of those guys. And in theory, I could just do this, get this object once, like maybe I will. Let's just get this out of the way first. Authentication ID. We'll do it that way. Right, so that way we're setting both of those guys. Yeah, I think I will tidy this up just a little bit. Let's do meta, self meta. Well, actually, I can just copy it this way. Let's do it like that. And then we can just do meta insert, and then format again. There we go. That looks a bit nicer. And let's just verify that that compiles. Oh, I've done something silly. Alright, this should be auth C. So there's this authorization ID and authentication ID. This is sort of like a nuance of the authentication spec. Normally, as sort of mere mortal human beings, whenever we log into something, we tend to think we have a username and a password, and that's our credential, that identifies ourselves. And that's how most things work. But the authentication spec actually allows you to authenticate as yourself, but operate on behalf of another identity. So that authentication stage allows you to express that. So there are sort of two principles, authentication principles, that can be passed in as part of that. Normally you only just pass one and you leave one of them blank, and that way it's saying I am me and I'm acting as me. But you can be yourself, but acting on behalf of someone who's given you privilege to do that. So they've authorized you to act on their behalf. So that's what these two things are. And so that's authorization is who you're acting on behalf of, and authentication is who you are. And that's what these two things are. They're often abbreviated like this because authorization and authentication are kind of long and they're awkward to type. So you can see I did it like once here, but then I got... I thought in the scripts, nobody's really going to want to type those things out. So I just made it shorter. So that's what these are. And of course I've got like 3 different variations on here because I love consistency. But there we go. So what that means now is we've moved those fields into that more general metadata from that message metadata. So it doesn't look like I've done very much. And the truth is I haven't really. I've done more talking than anything else. What I would like to do is, just to make sure that I haven't sort of made some kind of huge error in oversight, I'm going to quickly amend my sort of testing policy just to sort of print some stuff out. This is something I like to do. You can see I've got some commented out stuff in there. This is a file called simplepolicy.lua that's in the root of the KumoMTA repository. This isn't really for anybody else but for me to play with. It's just there for my convenience. But you can see like what kind of crap I used to do some ad hoc testing with. What I'm going to do here, there's this event called SMTP server message received. This event triggers right after we've done the data and we've like assembled the message. Basically that thing I showed you earlier where we were assigning those various fields into the message, those all get populated and then this event gets triggered. And assuming that I haven't screwed things up, what should happen when I send a message in, I should be able to see the effect of moving those authentication things around. Before I do that, I've just remembered I need to make sure you can actually authenticate against this. And how is this currently configured? Have I got like a simple check here? Yeah. So right now the policy is set up to do something that I don't recommend that you do, but in this case, it's a very simple basic test that shows. So I've got an in-memory username and password table here. Scott and Tiger so Scott's this test username, Tiger's the corresponding password for it. This isn't the default for KumoMTA. This is just some crap in a testing config that is for me. It's not what we ship with the product. So don't go thinking, oh, the default username and password for Kumo is Scott Tiger. That's crazy. It's not. But it will be what I use to verify this. So what I'm going to do, I'm just going to get this building over here while I talk a little bit. That will build the server. I'm going to run that server and I'm going to use a tool called Swax, which is like a Swiss Army knife of sending email. I'm going to use that just to do like a quick test for an authenticator to send into that instance. And I will print out the metadata fields that we just moved around just to make sure they show up in the message. So that's a very long-winded way of saying all that. You can see at some point in the past, I had previously done this here for the authentication ID. So I'm just going to uncomment that line. That saves me thinking about what I need to do. So that's good. I'm going to switch back over to this window now, where you can see that I have previously, or I have now finished compiling. I'm just going to run the server. This is just a way I run it ad hoc locally. I'm just going to tell it to use that simple policy, and I set the log information to info. That just turns on info level. This is actually the default, but this is in my sort of control R history since before I added that as a default. So that, anyway, that's going to run that server. You can see it's like started up on here, and it's an empty server. There's not a lot going on. So now over here, what have we got? Have I got something Swax-like? Yeah. So this is just a Swax invocation that talks to that server. So you can see if I just do a send, this one isn't authenticated, but you can see like it's sending the message. And if I go back over here, you can see my print just has user data nil. Oh, why is that saying user data? Oh, because the quoting is funny. I think that's what that is. Let's just restart that and try again. we have to wait a moment for it to shut down safely. The reason that it's taking a while to shut down is because my local network doesn't allow outgoing port 25 traffic. So that message I injected is currently kind of like in flight trying to get sent out. So while I'm trying to shut down, it's kind of sort of sitting there thinking like, oh, how can I finish my like active attempt to deliver this? So this is frustrating, isn't it? I'm just going to kill this. Like that. Actually, what I'll do, just for the sake of making this slightly less annoying during testing, have I got like a reject in here? Yeah, we'll grab one of these. And I'm just going to have it reject the mail instead. Like so. Oh, 555. Whatever you want to call it. So now, when we run this again, not only have I fixed that policy so it should print properly, but this should also give me like a 555. There we go. Right, so you can see that's rejecting now. And also my print statement still isn't quite what I expected. Okay, let's actually read that a bit more properly this time and see what's going on. So what happened there? And maybe it's just fine because we're not authenticated, so it probably shouldn't show anything. I think what bothered me was I got this, we saw that user data :nil in there, right? That's what troubled me about that. So, oh, I need to empty the spool from the last one. There we go. All right. So now if I do this, user data :nil. Well, that's not what I expected. Have I forgotten how it works? It's possible. Where's my message type? Right. Trees bar. This is weird, isn't it? Let's why is it not doing what I think it should be doing? Let's do a set meta root. Let's do that. So hopefully we'll see a woot here if we restart that and try again. Root. Okay. Yeah, what puzzles me is that it shows user data :nil in there. It's possible that we return a funky proxy object there for that. Let's have a look, see what that's doing. So that stuff lives in creates message rs, and if we look at get meta, I see. Meta object, get meta. I see. This might be a case of something where there's a little refinement needed. So as an explanation of what we're seeing in here, this message crate provides the KumoMTA message struct and object and accessors, and there's like a couple of related methods in here. You can see we've got like get meta obj, and get meta string. They're all slightly different. Get meta string returns it as a string, so it makes sure that it is a string. Actually, it's an optional string in this case. So if it's a JSON null, we get a none back at the Rust level. If it's a string, we get a some string. And if it's anything else, it's an error. That's kind of what I think what I thought we were calling when we called get meta in the Lua bindings. But the Lua bindings actually target this get meta method, which is slightly different. And the way that it works is it just returns the JSON value for that corresponding key if it's present. Otherwise, it returns SerDJSON null, and I think really it's possible that that should actually be calling get meta obj instead, also doing a little bit of translation so that instead of SerDJSON's sort of nil value, we actually return the Lua nil value instead. There's a lot of parallels between JSON values and Lua values. JSON is essentially a subset of Lua's values, broadly speaking. Lua can represent a few more nuanced things, but there's like a little bit of like proxying magic going on between them. So anyway, all of this is kind of a little bit of a diversion to come to the realization that it's fine. I don't need to sweat that at the moment. When it shows nil, it just means I haven't set the authentication ID because I haven't authenticated yet. But I may well follow up on this and just make sure that it's not surprising in the future, but I don't need to do that right now. Okay, so let's try this with authentication set then. I have to remember how to do that with Swax. Let's see. It has a lot of help. So we've got auth user. Okay, well, yeah, this might be very easy. So is there like a auth user and auth password? Oh, that should be very easy then. So if we do this and we do auth user, remember I said it's Scott and Tiger. Spell that properly. So now, really? Oh, okay. So it's saying we can't do that because the host doesn't advertise authentication. The reason that it didn't is because we're connecting over an unencrypted connection, and we only support auth plain, but we don't support auth plain on an unencrypted connection. So what we need to do is tell it to also do start TLS, and I think we just do something like this. No? Put enough keys in it, maybe? No? Right, let's do the help. Right. How do we do start TLS? Oh, TLS. But we may want to tell it that self-signed is okay. How do we do that? Insecure? Alright, let's just try TLS and see what happens. Ah, seems like that. Just fine. So let's see what happened. It says auth OK. That's good. And then over here we can see, brilliant, it printed out Scott. So anyway, that was a kind of a long-winded diversion. So yes, we successfully printed out that we authenticated as Scott, which is what we wanted. Okay, so good. Good, good, good. That means we're not crazy to do this. So what else do we need to do? We need to move those other set meta things over. Those I think can go actually when we set up this whole thing in the first place, because these are pieces of information that do not vary at runtime. So I think if we look for this bit, I think actually we can just put them pretty much in line over here. So I think we can use this kind of nice JSON macro as well to kind of save a little bit of faff. So similar to when a little bit earlier we did that as object mute to get at the underlying object and do some grubbing around. Don't really want to do that here because it's kind of awkward and inconvenient, but there's this macro that kind of makes it less so. So what we should be able to do is make this look a bit more like a JSON constructor using this macro. And then here, the only thing that I think might be a bit awkward is we might need to just sort of do this first. Yeah, let's do this way. The reason for this is these address and peer things, when we construct this SMTP server struct, we're moving them in down here. But we want to be able to reference them elsewhere, and we can't do that if we've moved them. So we need to make a copy of those first when we put them in here. So we'll just do that this way. What that leaves is the protocol And let's just see. I think it's always protocol. Yes, we always call it ESMTP. In the future, we might change that so it changes to ESMTP SA or something for the SSL authentication. But we're just going to set that preemptively up here to the same string, ESMTP. Spell it correctly would be a good idea. Something like this, and then like this. Oops. There we go. And then let's just verify that compiles. Oh, we need some colons here. Good. Now, what it's complaining about here is we didn't use that other protocol guy that we were looking at earlier. So let's look at that. Oh, look at that, we've got some unintended. I think I've intended to remove that one a while ago. Problem solved. Yeah. I'm going to leave a note to myself about this update. This way, if I do come along and I'm like, oh, I need to change the trace headers to show the right protocol, what I can do at the same time is just fix it so everything has a consistent view of the protocol. That's not part of this change, so I'm just going to leave a note for myself. And I will change it if and when it comes to it. Okay, so far we haven't really done much in the way of Lua, aside from like scratching my head over something I've forgotten how it works. But if I just look at the diff of what we've changed, just to refresh our memories of what's going on, what we've done is we've moved those assignments of the metadata into a more global version of the metadata. Okay, so let's format that. And so that was like the sort of easy piece. Now, what we want to do is we want to make that information accessible in those various hooks. One way we could do that is if we only wanted it to be read-only, we could just essentially just pass a copy of that data in as another parameter in those hooks. But really, what we want to be able to do is let you in your policy assign things to that as well. So, and there's two ways we could do that. And one is we could pass it in as some kind of reference and then kind of inspect it and sort of pass it back out again. Or another way to deal with it is what we could do is we could wrap it in a little wrapping structure and then pass that directly into Lua and then use some Lua meta methods so that update operations on that thing actually update the underlying data directly. And then we don't need to do any kind of reconciliation after the fact. Still haven't quite decided which one I'm going to do. I kind of like the idea of that last one because in the long run, there are fewer surprises. But it does mean it's a little bit more fiddly in the sort of short term because you need to add all the different accesses and things to it. And from experience doing that I think I've done something like that in WesTerm to kind of like bridge some like a Lua version to a JSON version. There's a few different bits and pieces there. So maybe that's what I'll do. And like I'll just copy the code that I've already written somewhere else and use for that purpose. So I'm just going to take a sip and I'll try and remember where I put that code. So I have done memoizing in here. Yeah, so I think if you will forgive me for not showing only KumoMTA code, in this window, I have some stuff in WesTerm. WesTerm and KumoMTA have some similarities in some of this Lua handling stuff. This may actually work out fine. In WesTerm, there is a facility called Global that allows you to stash state in like a shared in-memory map essentially, and that map then points into sort of shared references to some JSON values. That's kind of what we want here. We don't need that kind of magic, like that first layer of like mapping lookup. We want the thing that lets you go and access those internal guys. Now, where does that live? It's somewhere here in the WES-term code. That's not very helpful. Let's do Rust. Oh, okay, I've made it into a little crate called share data. Fantastic. So if we open that up, what we will see is... Okay, and we've got... Oh, actually, this is a little different. This actually doesn't use JSON values. This is using Lua value. Oh, no, value is Lua value. Okay. So what's value here? Is it its own type? I see. Oh, this is a type that looks very much like SerDes-JSON's value, but it has a few different constraints. Okay, so I don't think I can use this directly, but it has all this mapping stuff here. You see there's a surprising amount of stuff you need to do to kind of bridge the two things together. Even though they look very similar, there are enough differences that it's, you know, a bit of stuff going on. I think this is the part I wanted to refresh my memory on. So in both KumoMTA and in WES-term, we use a crate called mlua, which is a really nice library for providing type-safe manipulation of Lua's runtime. One of the things that it makes very nice and easy to do is implementing. Lua has like a user data type. So in Lua, it has a number of sort of built-in types for things like numbers and strings, and its table type, which is like a combination of hash table, an array, an object, and all sorts of things. But it also has this idea where you can pass in a user data, which in the underlying C API is essentially like a void star pointer, which has no sort of intrinsic, Lua itself has no intrinsic knowledge of like what that does, but it allows you to associate a set of meta methods with the user data. So like it has your void pointer, and then it references to like this set of meta methods, which is a Lua table with some methods in it that allow you to kind of define different actions for things like indexing, concatenation, assigning new indexes, and all sorts of things. So if we were to map our context type into Lua and want it to update the real underlying thing, we would want one of these kind of meta method things here. And I think this is kind of the thing that I think we want to look at here would be these guys, where we've got so pairs is like the Lua way of iterating over a table, and you can see like it handles whether it's an array or an object type, and we've got other things here like index, which is where you sort of read either an array index or a hash table field. So this is the kind of stuff here. A lot of this I think we could copy but adapt, because like instead of using this crate's version of the value type, we would use the Lua version of the value type. And we've got here like new index, which is assigning to a field value. And like here you can see there are different cases for like whether it's an array type or whether it's an object type. And you know, it's kind of a lot of code, right? So what is that? That's line 468 and that's line 268. So there's like 200 lines of code for that, which is kind of a lot. And do I want to do that? I don't want to just kind of crap it into the SMTP server code. What that might mean is like maybe there's some scope for making a more general accessor for that. I don't know that I want to do that for this feature for the live stream right now. What a dilemma, huh? Because I think it would be easier to do something else, but it would be hacky for someone in some way. Yeah, and I think actually it's possible that we could do maybe a subset of this, right? So this is an example of like a full-blown thing. What I might do is I might write like a lighter weight thing to represent that context. So let's do this. Let's do this together. So let's find a spot. This file's getting kind of large. Ideally, I'd put this in another file, but I'm just going to stick it in this file for now. So what I think we'll do, let's define a struct for this. What we will call it is connection metadata. And inside connection metadata, we are going to have a JSON value. And that's what we're going to use to store that metadata that we have in the SMTP server. In fact, let's split that and get it to do that right now. Wherever that is. Right, here we go. And we'll just say connection metadata. Let's do this as like a first round. Just make sure things are happy with it. So I jumped away quite quickly there. So what we all right, it's telling me, hey, we're missing like some kind of constructor around that, so I can't just stick it as is right there. What we need to do is do connection metadata and meta, and that will be happier. And then it's got this like meta as much. Remember, we wrote this just like a few, ostensibly a few minutes ago. This as object mute thing where we're like trying to assign some stuff to it. This is a good opportunity to refactor that away, actually. So, because it's suggesting, hey, we should probably put this like .0 thing to go inside that tuple struct. That just makes the code look more ugly, and like we're writing a wrapper around it, so we might as well just do something nice about it. So what we'll do is we'll make an accessor for that. So let's do set meta, mutable self, and then what are we going to do? Name, string, value, JSON value. Like so. And what was it as object mute? This guy. Now, because we're putting this inside a wrapper, yeah, actually, you know what? Let's change this a little bit. We'll do this properly, or properly. What we will do is we'll make a proper constructor for this. So the only way to assign that value, in theory, is by calling the constructor. This way, we know, because we're the only way that we can do it, it will definitely always be an object. And because we don't allow exposing that internal state, no one can change it from an object to something else. Okay, so that will be like a precondition for use of this. What that means is now we can do something like this in here, where we can do yes, self value. Oh, actually, let's call that map. How about that? Map as object mute. I'm just going to put expect here now, because this is an impossible error situation now, because we've guaranteed that it's impossible. I'm fine with using expect as opposed to propagating an error. So we'll do that. And then we can do meta insert main value. Right, so that probably will compile-ish, that bit. The other bits are going to complain because they don't know how to deal with this other stuff. Right, we need to update it to use the constructor. Oops. So that's what we'll do. Oh, except, I forgot, we were actually passing in some data here. Damn it. So actually what we'll do I know that JSON constructor is kind of handy. We will just rejigger this a bit over here. Oops. And then we will do like this. Now, this isn't going to compile, but I'll make it so it compiles in a moment because this is nice. And I'll explain what I'm talking about. So let me just do the sort of boring mechanical bits first. Right. So this should still not compile. Right. So okay, and it's showing some nice error messages. So it won't compile because we defined this as a JSON value, but we've passed in like a string reference here, and it's obviously not the right type. And it's saying we can fix it by calling .into at the place where we call it. But there's a better way to do this, or not necessarily better, but a more ergonomic way of doing this. And in Rust, we like saying ergonomic. So in our setMeta method, what we'll do is we'll make it generic over any value as long as that value is convertible into a sturdy JSON value. So we'll do v, and then here we can do value.into. So we're still doing what the compiler said, but what we've done is we've moved the .into inside this method. And now, assuming I know how to Rust, what should happen now is it won't complain about that particular call anymore, right? So it will let me just pass in those literals, which is nice. But now it is complaining about something else here. Oh yeah, the actual original bit of code there on line 904. We don't need this bit anymore because we can now just do self meta, that meta. And here we don't need that toString. And actually here, probably we don't need that either, right? So as you can see, this is actually making the code look a bit tidier because there's sort of less guff, right? So hopefully that compiles. So, sorry, I was just looking at the comments on the chat. I'm not very good at looking over. There's this little screen over there. It's tiny text. Hello, everyone. What do we got? Do it live. Yes. Which wrapper is going inside? Oh, MC Hammer. Yeah. Especially because it means people outside can't touch this. And Scoopy Noodle says, hi. Hi. So there we go. Right. What do we got here? It's talking about now, there's no clone method in ConnectionMetaData. And that is true. There is not. So let's go look at that line. I know what that line is. This is the one from the start where we were building the message. And I said we could just simply clone the metadata because it's a sturdy JSON value and just stick it straight in. That's true, except not now. Now we've put it in a wrapper. It's no longer the same type. So we need a way to get at the inside of that, which we will add. What do I call it? ConnectionMetaData. So what we can do is we can just provide a method to clone inner. Just because naming is hard, and this describes what it's doing. So we'll do self map clone. And then in this other thing, we'll do self meta clone inner. So that should just copy the inside part into that and pass into the message. Oh look, what's going on here? Meta name. Okay, Okay, this is kind of similar to that thing earlier. Because we're passing in a string reference, that's convenient for us as callers, but the underlying sturdy JSON map wants a concrete string with a capital S. We could change this to require passing in a string, but then the callers have to do like .toString or something. It's kind of a pain in the butt. What we'll do instead is we'll define a name type that is anything that can be converted into a string. Like that. Yep. And we'll give it n. and then we'll just do, oops, where are we? Name.info, kind of the same deal. So that should solve that, hopefully. Yeah, job done. Well, not quite done. Making that silly little wrapper is done. So let's load that. I'll just format and load it. So what have we gotten to? So you can see we've moved from just being a raw value into a metadata wrapper. We've sort of moved things around. We've got sort of reasonably nice construction going on now for the sort of global stuff. There we go. Wow, all that talking and still not a lot actually written. So we've got this wrapper now. What that means is we should now be able to expose this to Lua. And in fact, let's do that bit. That's actually pretty straightforward, doing it read-only. We'll do that as like a first pass, and then sort of satisfy ourselves that that policy that we did earlier is still hanging together. Then we'll do a pass to add like the ability to update this guy. Yeah. Yes. Yeah, I'm already thinking ahead for how I would do that bit. Let's do the user data side of this, right? So I've switched over. This is that other code in WES-term. I need to implement this user data trait. Let's just try passing in it. I'll try adding it as a parameter to one of those events. The compilation is going to complain that it doesn't implement this, but you'll see the progression, because otherwise it's just me sort of conjuring things from out of thin air and you going like, how did he know that? I know because I've done it quite a few times, but I'll show you like why it wants that. So let's go to the EHLO event, right, which is like that first one. It just so happens I landed straight on it as soon as I searched for it. So this piece of code is in the logic in the SMTP server. It's parsed the incoming request, and it's decided that it's the EHLO, and it's passed out the domain. Right. This, if you remember, if I pop back to the docs from earlier and I go to the events, you will see. That's what this is. If you remember, if you were with us back at the start, we got the EHLO event, and it's being passed the domain, right? So this is literally the code that has parsed the domain out, and now it's going to call a callback and pass in that domain. So logically, what we want to do here is pass in that metadata now, right? So we do something like this. That's how we just add a parameter to that event, right? Except it won't compile. And like here's why it won't compile. It's saying, oh, actually, for two reasons. One is I have to pass it as a tuple so that the multiple arguments get passed together as a pack, and then it's a Lua thing. So let's try this again. Right. So now there's a much more verbose set of errors going on, and it's not immediately obvious just because of the sort of magic that happens in mlua. What it's saying is the parameter that we passed, it doesn't satisfy this to-Lua multi-trait. So in Lua parameter parsing, a lot of this stuff is done through like a tuple of parameters packed together. So you can pass multiple things as a unit, but also receive multiple things back. So like the return value from calling a Lua function can be a set of values rather than just a single value. In mlua, it wraps those things up in like a pair of symmetrical traits called to-Lua multi and from-Lua multi. And essentially what they do is implement another trait called to-Lua or from-Lua over individual values that are in a tuple, which is one of the reasons why down here you see this kind of like ever-increasing size of tuples saying like these types implement to-Lua multi, and it's like a tuple of A, tuple of BA, BCA. So basically there's like a whole bunch of these things and 9 others of like increasing length of tuples over which the trait is implemented, but each of the elements in the tuple must have implemented the from Lua or to Lua traits. So this is a kind of indirect way of saying our connection metadata type that we've defined doesn't implement that trait, which means that that whole tuple doesn't implement this trait, so it doesn't compile. Okay, so what does that mean? It means we need to implement that trait here, the user data trait, so that it will compile. So let's do that. So we'll switcheroo. There's my connection metadata. So what we need to do for this is import, what was it, user data or connection metadata. And if I just implement that, that's an empty implementation. So we're not really doing anything special to implement it. But we've sort of said, hey, we want it to do that. Oh, and it's sort of saying, hey, I actually need to import that to do that. So let's just do that. So that this way it knows what the trait actually is, rather than sort of guessing what it could be. So now you can see we've got a more intelligible error message. What it's saying is connection metadata needs to be clonable, otherwise it's no good. What it's suggesting is we simply derive clone on our struct. And I'll do that for now, but that isn't actually really what I want to do. And I'll explain that in a moment. We'll just make it clonable. We'll get it to compile, and then we come back to this clone business. The clone trait allows the structure to be copied. Lua needs to be able to copy stuff because a lot of what it does is it like pushes things onto a stack and copies things around, so it can have multiple copies of something, even though logically you might have only thought you put one in there. But it needs to be copied. Now what it's saying, now it wants it to be copied. So clone allows it to be copied by calling clone explicitly. The copy trait allows it to be copied implicitly. So it's a kind of like a simple kind of bit level structure copy. What it's saying right now is the way that I passed the parameter to that event, it needs to be copied because we didn't explicitly clone it. We can go do that. We don't actually want to clone it because really we want to be able to update this thing. But for the sake of getting this stage of the example to compile, I will make a copy for the moment. But if we want to be able to update it and have that reflect in the original structure, making a copy is no good because the things that you change in the Lua script won't actually change the actual data that we carry on for the rest of the server. So cool. So this now compiles, right? So now what that means is we have a new parameter being passed in there. And if we go into, do I have the EHLO in here? Yeah, I do. So if I now put in here, we'll just call it ConnMeta. What I should be able to do in here now is during each EHLO, we'll print this out. It'll probably just say something like user data because we haven't defined any methods on it. But if I build the server now and run that guy, you will see it will print user data. Or you could just take my word for it. But we'll show you. Rust compiles not the fastest in the world, but you know, just really thinking about it. There we go. So if we run that, and then we get rid of that bit, we'll just do a swax. So now you can see there's two EHLOs. That doesn't surprise me. Because we turned on TLS, what happens is the client connects, says EHLO, sees that TLS is available. Then it does the start TLS negotiation. And when that's successful, and this is one of the things in the RFC, like it may issue a second EHLO. But if we're using auth, then we may also issue a second EHLO. So like the 2 is fine. Like 2 or 3, I think are fine here. 1 would be very suspicious because it means like it's sort of not doing any of the sort of things it should do after authenticating. But you can see, so there's 2 of these guys. These are very slightly different. Like the last 3 digits on these are different for the user data. So that's really like the pointer to that connection metadata struct being passed in there. So that's fine. And actually, because they're different, it shows you the clone would be no good, because like, say we wanted to store some information between one EHLO and the other. Like maybe in our policy we've decided to count how many EHLOs there are on a connection for some reason. We wouldn't be able to here because we would have kind of lost that state. So we don't want to do that. So what we want to do is we want to make sure we can share that guy. So let's do something about that. So in Rust, one of the easiest ways to share something is to use an arc. And an arc is an atomic reference counting wrapping variable. So in our wrapper, we have a wrapper. So I might need to import something for arc. Oh no, I've already got arc in scope. So if I throw an arc around that, I'm going to need to sort of adjust some stuff here. So we'll do an arc new of that guy. Now the thing is, whenever you use an arc, you can't just use an arc if you want to change something. So we're going to need a mutex, because what we want to be able to do is change the value that's inside it. This looks a little bit hinky, but so now we've got an arc of a mutex. That's fine. This we need to go sort of adjust some stuff. So when we assign values now to this guy, we don't just need the map. We need to get we need to lock the map so we can have a mutable reference to that guy. So let me show you. If I compile, it will error out because we've got the wrong type, right? We've got an arc mutex there as opposed to the map. So we'll do map self map lock unwrap. This lock unwrap is one of the very few places where I'm okay with a naked unwrap. I think this is like a usability warp on the built-in mutex type. There's like a parking lot mutex that doesn't have this. And just often I'm too lazy to import that instead of the standard one. So anyway, that gives us the map. So instead of doing that now, we just change it like that. So I think that will do that bit. Good. And then we have like a similar issue now with the clone inner method. What it's saying is our underlying type isn't SerDes.json value, so we can't just clone the mutex value and hope that that's right. We need to lock the inside of it and grab it. So we'll do that there. Same treatment. Okay, so that kind of works, but we haven't sort of fixed that clone issue. And actually, no, actually we have fixed it. So when clone inner is called, we will make a copy of the internal information, which is actually what we want. Like if you recall, that clone inner, we use that when we go to create the message. So we actually don't want to tie that version of the information to the one the server is using. Partly because the intent is that this is supposed to be a snapshot of that state at the time the message was made. This is the main reason. And if we were to literally share that state, then subsequent events happening on that incoming connection could change the value that we've associated with the message, which is not how it's supposed to work. Like, we could make it work that way, but like I think that would be kind of a crazy choice. Like you couldn't really reason about what the value had or really what it meant. So that's like not a good idea. So having clone inner explicitly clone the inside makes sense. And now the name of that method makes a ton of sense. It's almost as if I planned it, which we can pretend that I did, but really I was just kind of doing it off the cuff. Now, what I did plan was, because we're using the arc around this now, when we actually clone the metadata itself by calling self-meta.clone, which is, if we go back to that EHLO hook, that's what we're doing there. Now what I'm hoping is that we actually see the same underlying user data pointer. I don't know if that's exactly what's going to happen, because even though I made the claim that those two were the pointer values, they may have been a slightly different pointer value. But let's compile it and see. I think We'll do a test to sort of assert that is working for ourselves by like we can tell that in and do a pair of EHLOs or something. Oh, we need to add a method to update it first, right? So we'll get to that. We'll prove it to ourselves in a little bit. So if I run this and do this, okay, we still have two different pointer values here, but I think it's probably okay now that the implementation is slightly different. So in order to prove it to ourselves, we actually need to define some methods in this user data thing, right? So yeah, we claim to conform to that trait, and we do, but it's not useful to sort of do it without any internal methods for something. So we need to add some. If we come back over here, the main thing we need to do is plumb some stuff in here. So we've got this add methods, like, oh, that's the wrong button. I could copy this from the docs. Normally I do. Normally I switch to the docs for that and copy it. Like I just have this handy over here. It's just because I've got so many examples of it. So have we got like an add method in here? Not in this one. So we'll do this in a second. Here we go. Methods, add method. We'll look in here. Let's grab it from there. All right, here's an example of a set meta method and a get meta method. Why don't we let's copy those. Those are the ones that operate on the version of this that lives inside the message. I want to intentionally mirror that API, even though the implementation details might be slightly different. Now I've just copied those. Let's just read them before we try to compile and see like what are they actually doing. So what we're saying here is one of the methods that is part of this user data trait is one that says add methods. The way this works is when mLua is setting up the wrapping machinery that goes with passing in the user data for this, when we pass it into Lua, it's actually creating that meta table that has the information about what methods are available. And so like this is the thing that sets that up. And it passes in this methods object that implements a user data methods trait. So it's kind of a bit abstract and indirect. But we're saying, hey, we have a method that we want to call setMeta, and this is a bit hard to read at first glance, but it's saying here is a lambda, and you can tell it's a lambda because of these bars, and that lambda accepts the first parameter, which here we're saying we don't care what the first parameter is. So in Rust, you just tend to use underscore for like, I don't care. But in practice, what this is actually a reference to the Lua context. So if we needed to do something somewhat clever, we would fill that in and do some stuff with it. But here we don't need it. This next parameter, it calls this. This really is a reference to the ConnectionMetaData struct itself. So that gets passed in. And then the parameters that get passed in. So I mentioned earlier, like a lot of things in Lua are sort of tuple based. So this bit is kind of a funky way of saying that here's a tuple. It consists of a string and a Lua value, and we will assign them the name and value in the lambda. So it looks a bit weird. This is essentially defining function parameters, but because of the way they get kind of packed and mapped in here, you have to use this funky tuple syntax. So then what it's doing is it's saying, what is it doing? Okay, so this bit of logic is converting the Lua value into a SERDI Lua value, and say if there's any errors, like propagate those and like return those back to Lua as a Lua error, whereas normally it would be like a SERDI JSON, SERDI serialization error. So that converts the incoming Lua value into a SERDI value, SERDI JSON value, and then it calls setMeta on the underlying object. And actually, look, it's like, again, it's like I planned this, where it calls set. So the idea is that it calls setMeta and passes that information inside, and then maps the error message. So this stands a chance of assuming I've got the right things imported, this may actually compile and do actually exactly what we want. But we don't have a get meta method, so and we should, for the sake of not just symmetry, but because we also need that for the Lua script, because it's kind of the point. So we can add a get method. What we can do actually, if we may be able to just borrow. Oh, that's interesting. What was it called? Oh, I see. Okay, that's why I didn't match. Why don't we? Oh, wait, copying this isn't especially useful. Okay, I was just trying to be lazy, but it would have been more work. So let's write a get method, get meta. This is going to be kind of similar, but it's going to be a bit different. Because we're doing a get, obviously we don't pass in a parameter, but we can return an optional value because it may not be set. So what we'll do here, when we get, we actually don't need to mutate, so we will make it so we don't need a mutable reference. Doesn't really matter because we use an interior, like a mutex internally. We could make both the set and the get be a constant reference, right? Just a standard reference, because the mutex is actually what gives us the mutability to access the inside stuff. But it's just nice to sort of have this parallel for the logically the mutating stuff should have that mute on there, unless you're doing something clever where you need it not to do that. So anyway, so here, because we don't really need it to be mutable here, we'll take that away. So we're just reading it as an object. And then here, I think we can just do get. And actually, what I think we can do here is as ref scrum. And I think this might be slightly nicer because what I just did there was for our set method, we made it so it implicitly created a concrete instance of a string. So you could pass in a literal or a string you'd already made, and it would end up as a new string with a capital S. But when we do lookups, we don't necessarily want to create a copy of a thing just to say like if a value exists, especially if we've already got a literal. And Rust's hash table stuff, it has a few tricks that it does where it doesn't require you to make a copy of something. So there's a set of traits where you can borrow. So you can borrow as a what's the type I'm looking for? There's like a borrow trait where you can borrow as a different kind of reference from the actual type that you have. So the capital S string type can be borrowed as a str reference, and you can define your own types that have kind of similar kind of relationship. And also you can even define your own non-stringy types that have a similar thing where you can borrow them as a kind of reference version of a struct. So that makes it feasible to make lookups very cheap, right? Even if your key is kind of like big complex structure, if you've already got the individual pieces allocated, you can make a thing that borrows references to those and use that as a key in Rust's hash tables. It's a little bit fiddly. A friend of mine who I used to work with a while back wrote up something about that. I'll post a link to that in the video description. So it's kind of a neat trick, but it's already done for you for things like string types. So anyway, the point is like here, technically I should probably use like the borrow. Let's look it up. That makes me sound more authoritative if I'm doing the right thing. So if we look at the Rust hash map, if you look at the get method, yeah, you'll see that it has this queue type, right? So like the hash map itself, if we go up to the top, oh, it's quite a way up. If we look at the hash map, you'll see it has like key value and then like a random state for making it more like defensible against weird attacks. But really the thing that we care about is the key and the value, right? So it's normally like a string. In our case, like these maps are like a string and then like a serde JSON value. But if we look at the get method, it has this Q type. It's defined as a generic, and it's saying the key that you pass in for get needs to be like a reference to a queue. And what it's saying is where the key type of the map implements borrow as queue. So it's actually the other way around. So what it's saying is as long as you can borrow as a queue, and queue is also hashable and the hash is consistent with that of the key type, then you can actually look up with either concrete instance of K, the key type, or Q, which is like some kind of referencing type that you've got. So if we drill into this borrow, there's a whole lot of explanation in there. I'm not going to go into all this right now, but you can see this is a long list of stuff going on, right? And they've got an example of doing like case-insensitive string lookups and stuff for a hash table. But anyway, you can see at the implementers, this is the thing I wanted to show is there's this borrow of str is implemented for string, and that allows this sort of use of either of those two types in as a key for a hash map whose key type is defined as a string. And there's like similar for like C string and C str, OS string, OS str, path buff and path. So a bunch of the built-in standard library types have this relationship predefined, and things like what have we got here? There's like a arc dereferences the things inside, or a vec kind of dereferences or borrows as like the underlying slice type and stuff like that. So this is kind of a powerful thing. So technically, if I was being super good about this, I would define these two constraints on here. But because I'm lazy in terms of writing code, I think I can get away with just doing as ref of str, and it's probably good enough for this use because I know it's a string. And it's just much simpler to do it this way. Assuming it compiles. Let's see if it compiles after all of that explanation. Oh yeah, so I need some imports. Let's grab those. User data methods was one of them. This config any error. I mentioned that any error in like the last stream I did. That's just a sort of helper function that kind of maps an arbitrary error into like an internal mlua error. Oh, okay. So here's one that's worth explaining rather than just sort of fixing it straight off the bat. There's this toLua thing. So if we look back over here, where was it? To value, right? Lua to value. What this is, mlua has an optional feature which is compatibility with serde. And for the sake of those who don't know, serde is Rust's serialization, deserialization library. It's really nice. You can derive serialization on all sorts of things, and it's like extremely low boilerplate. It's fantastic. You can do some interesting things with it. So mlua allows you to essentially serialize to and from Lua values from and to serde serializable data types. So in this getMeta method that I haven't really explained because I just kind of threw it together. In this getMeta thing, what it's doing is we get the result of this assignment here is we get a serde JSON value returned from the getMeta method that we implemented just up here at the top of the screen. Right, it's a serde JSON. So we get one of those, but we want to actually end up with a Lua value because we're passing it to Lua. If we wanted to be, what's the word? As kind of like high effort as that other piece of code I showed you in WesTerm earlier, we wouldn't map it into a Lua value directly. We would like have another wrapper type around that would implement all of the meta methods and so on. I don't think that's necessary. Has some limitations for not going that like whole extra 10 miles. But for the sake of this example here, I don't think it's necessary. So what we want to do is just map it into the Lua value. And I mentioned earlier that first parameter, right? That first underscore parameter from over here, I said it's the Lua context and we don't need it unless we're doing something clever. Well, clever in this case is we kind of need it because you need that Lua context to be able to construct Lua tables and Lua strings and have them associated in that context correctly. And converting to a Lua value does need to do that for various fields and things. So this Lua.to value is a method that is implemented on the Lua context, but it's implemented as a trait, this Lua ext trait, which is what it's complaining about down here in green. So in order to call that toValue method, we need that trait. But that's the one that does that heavy lifting, so we don't need to do all that extra boilerplate. Not boilerplate, all those extra meta method implementations. It has a bunch of those, and we're happy with that trade-off. So now this will compile slightly better, but there's another issue lurking in there, which is this option business. What's it saying here? Oh, and also because we're returning a reference or something here. Let's have a look. We said we're returning a value, but the code we wrote returns a reference to a value. So we should change that. Should we change that? We must change that because in theory, I could just stick an ampersand in there and sort of say, yeah, that's kind of what I want.
I don't understand.
Whenever I say theory, my HomePod gets confused because it sounds like a word beginning with S. So conceptually, let's say, if I could say, let's return a reference to this, and the code would almost let that work, and like the caller would be happy with that. And the advantage of that is like I wouldn't need to make a copy every time I read the value, but because we have an interior mutex, so we've got like this interior arc and a mutex, we can't return that reference without also extending the lifetime of the lock that we held around the internals, right? Because otherwise, if we return the reference and release the lock, we've got a dangling reference. And in Rust, that code just wouldn't compile. It wouldn't let us do that. It would rightly say that's not going to work. We could explicitly annotate this function to allow that by returning out a mutex guard of that thing. So this mute map thing that we get over here when we do this lock unwrap, it actually builds a mutex guard which holds the lock and doesn't, it allows you to sort of say like, I'm holding the lock and I need to access the insides. So we could do that. I don't want the API to do that because I think it's kind of unnecessary guff, to be honest. And I think it's okay to just make a copy. The values that we have in these things are usually quite small anyway. So like the cost of the copy is tiny, and it just saves some headaches from like managing like the scope of the locks. So like in general, you want to avoid overlapping locks because that's how you end up with like deadlock problems or priority inversion. If you want to be like more precise, so if you you can't have a deadlock if you don't hold any locks, right? So we'll just make a copy, which is easy to do here. We will do cloned. That should make a copy of that thing. Right, so now this is complaining. Oh, right, so what this is saying is, on the code I copied from elsewhere, it has this map error after calling setMeta. For our purposes, our setMeta can never fail, so we actually don't need, there's no error case. So that actually just simplifies away. We don't need to map any error because there is none. And then we've got like what's this? This is a similar sort of thing, but slightly different. Here there's not an error case, but we need to handle the sort of none case. So what we will do, instead of trying to map the error, if we've got a value, we will get the value. Otherwise, if we've got none, we will just return, what is it? mlua value nil, I think it is, something like that. Oh, you know what? Maybe I'll just do it this way. Oops. Like so. Right, I think, let's see if that compiles. Expected option value. Oh, is it because I don't need a sum on that. I'll explain this in just a second. Let's just make sure it compiles mostly. Okay. I'll come back to that error in a moment. So what those changes do is we call getMeta. GetMeta from up here either returns an option of the value. So if there is one, it returns it. Otherwise, it's none. So what we say is if we've got the value, we map it into the Lua version of the value and return it. Otherwise, in the none case, we just want to Lua nil. This, if you were here and remember, we spent a few minutes earlier on saying, I wonder why that printed user data nil. This actually will sort of make that user data nil thing kind of disappear when you access this particular meta thing. Like this is probably something I should do for the message meta as well, but not in this stream. So, okay. So now what it was doing there is it was complaining. There's an error here. This first one is I just need to remove that mute. That's easy. This second one though is it's saying I've assigned something to the metadata, but it's saying we don't have a mutable reference to it here, so we need to make it mutable. So, and it's right. I think we just need to do this. To say it's a mutable method, so that way it makes this thing mutable. Let's try. Yeah, and then we can fix that other guy. 1279. Because when we don't need to mutate, and it's saying that was unnecessary, so we don't do it. Okay, so what have we done? Let me just take a second. Okay, so we made a wrapper type. It now has getMeta and setMeta methods on it. Let's see how these things work here if we put them in our policy. Let's call getMeta, what was it? Authentication ID. So whenever we call ehlo, we'll print that out. Let's build it. Yeah, so previously, right, it showed user data and then a pointer value. And then on this one now, we should show the authentication ID. And we'll try running that SWAC string again and we'll see what it shows. As soon as it compiles. There we go. So we run it. We run the SWACs. And, oh, that's disappointing. Oh, I guess because we don't ehlo again after we've ehlo'd. That's all right. The spirit of this is correct. What we'll do is we'll just pass this into more of the callbacks. So if we go callback, we'll just stick this in all of these guys. Right, so I'm adding it to a get listener domain, which is the sort of motivating example. I won't. I mean, we could. There's no reason I can't pass it in here. Let's just do it. I don't know if it makes sense necessarily to vary the status of authentication based on that context, but like, why not? In theory, that's supposed to be like a pure, like, are these credentials correct? Yes or no? But like, if we pass in connection state, in theory, it means that callback function becomes less pure, right? In terms of, it varies by more parameters than it did, so it becomes a little harder to reason about. But there's no reason we can't really do that. It's not a requirement for it to be strictly pure. So yeah, here's the hello, right? So we were looking at ehlo, which is what any reasonably modern, where modern means in the last 20 years or more, version of an SMTP server should be doing. But we also support hello. We support hello by mapping it to ehlo, just so we don't have like two versions of that thing. That's just how we deal with it. I don't think it matters. I don't think it matters that we don't do hello as opposed to ehlo. So all I'm doing here is I'm just adding Oh, I realize I'm adding the same tuple bug to all of these that we had earlier. So let's fix that. I'll make another pass over these instead. So self meta clone message so meta clone. For the message received hook, like probably most people aren't going to use that additional final parameter because you've already got a copy of the meta in the message. But maybe you decide something and you want to set it in the metadata for like a subsequent message reception. So I can see value in that. That was already in a tuple. That was in a tuple. That's in a tuple. Okay, so this might compile. Let's see. Good. All right, let's get that building. What I think will be useful here. Let's prove to ourselves that we can set something in one of these callbacks and we see it in a later one. So I'll just set example to yes at EHLO time. Then what we will do is in the message received, we will add that con meta because all these parameters now, all these events now have an additional parameter on the end. We'll just print out on meta get meta example, and we expect this to print yes or not print. So assuming that works, the idea is when we get to the message part, message received part, we should show example ? Yes, and if it didn't, it will show nil, and then there'll be some head scratching. But I think we've done this right. So there we go. So you can see, I can't remember what I'm looking up in the EHLO. Why does that print nil? Oh, because authentication ID isn't set. Yeah, right. So yeah, this is nil because we're not authenticated in either of the EHLOs. That happens later. But then finally, when we get to the end, we print out yes because both of these set that example key. So this seems to be working, right? And in fact, let's also, well, not that one. For the sake of showing that these things are here, we'll do that and this. And you can see that both the message and the connection both have Scott set, which is kind of what we expect. And then for the sake of, we actually don't do it in here, but like I guess we could. The original goal of this was to be able to say, I want to change whether relaying is allowed based on who they're authenticated as. So let's just write up like a version of that, just to satisfy ourselves that we really are doing the right thing. So we look at this. It takes domain and listener as the parameters, but now also what do I call it? Con map. And the idea is in this guy we need to return make listener domain of something. So we do something like this. If we do this, it will allow relaying to anybody. Now, in practice, if you put KumoMTA on the public internet and you implement this get listener domain event as written like this, essentially you make it an open relay, which is a very bad idea. It means anyone can relay mail through you to anybody else. So anybody that you can send mail to, you allow somebody to send to them through you, which is bad because they will take advantage of that, and your sending reputation will suffer. So you don't want to do that. This is an interim piece of code. So what I think we want to do is something like relay to false. Relay to is relay to. This will make a thing whose relaying depends on the value of relay to. Hack the planet, yes, an open relay. Showing up in the chat. Yeah, we don't want those. So yeah, what we want to do is change the value of relay to depending on the result of authentication and the domain, right? That's the kind of stated goal of this thing. So obviously we need to look to see who they are, right? So we will do ConnMeta, getMeta, authZid is what we want. So this is the principle that they are acting on behalf of rather than who they claim to be. In practice, if you don't distinguish between the two during authentication, both authID and authZid are the same thing. I'm using authZid here because it's technically the correct thing to use in this case, but you could just use authID. Like, it depends on what your policy is and whether you care about that or not. So anyway, there's that. So if authZid then, so if we are authenticated, do something. And in this case, we kind of want to see, let's do what? Auth to domain. So we'll make a little mapping table here. So what we'll say is Scott. Ooh, this table syntax is a bit funny. I'm doing this as a quoted string here. So we'll say Scott is allowed to mail to example.com. But nothing else, right? This is like a simple mapping. And then we can say if auth to domain authz is equal to the domain, and this domain is the one coming in here. So this event gets called at a couple of places in the incoming SMTP transaction, and it gets passed like the mail from or the mail to sort of say like what, you know, which way round things are. So this relay to, we're saying so if the incoming session is saying I want to send mail to example.com, this will get called, and our goal here is to populate the information about example.com. This listener domain struct contains like the information about who is allowed to relay to and who's allowed to relay from. So in this case, we care about to, and so we want to say we'll send to relay send to example.com. We'll allow Scott to send to example.com. This is kind of the logic we're coding in here. Provided they're authenticated as Scott, right? So if they're authenticated as Scott, they can send to example.com. This mapping, in practice, this might be like might be a data file, it might be like a SQLite database, it might be some other more remote database, like an external database. For the sake of this example, this Lua table is our database, right? But it could be any of the things that Kumo is able to talk to. So we're going to say if the authenticated user has an entry in auth to domain and that matches the domain we're being asked about, then we want to set relay to equal to true. Right. So I think that's the logic we want. Let's see if that works, shall we? So here let's do this without authentication. And it says relaying not permitted, which is what we expected. It didn't explain that in much detail, but that's okay. Actually, we're sending to the wrong place. We're trying to send to me. Let's try to example.com, which is not a valid email address, by the way. I don't own example.com. You cannot send email to example.com. but this logic doesn't care about that, so it's okay. So here we also get a relaying not permitted. But if we grab this auth and TLS stuff again and stick that on the end this time, hopefully it will go through. Yes, it did. Cool. And if I typo my password so it's incorrect, then auth fails. So obviously I can't get to that point. But there we go. Okay. So I think we've kind of proven that. Let's kind of review what the state of that code is. What have we got? So we've got some stuff that does some set. Okay, we're passing a bunch more things in. We've got a fix me for future me. We've got a lightweight wrapper around this stuff. We know we can share the state across the sort of different phases of the SMTP conversation. Got some debug in that script that I'm not going to commit, so I'll take that out. And I need to update the docs, and that will be. I'll show. In the previous stream, I was like, I'll spare you the details because I think it was going to be kind of boring. This is going to be kind of straightforward because it's essentially just adding that parameter in there. So let me just back out all the stuff I did in there. So if we look at the status, it's just one file so far. Then let's find the callback stuff that we changed, and we'll just go update those. So get listener domain. So I haven't shown you guys the docs before, but they're quite straightforward. So the events live under a directory called docs reference events. So we're just going to go update the information there. They're just markdown docs. So get listener domain. There's a little bit of guff we need. So I'll show you what. Yeah, I'm not going to do the docs update as part of this for real. I'm not going to check it in. I'm going to show you like roughly how I would do it with this one. The reason I'm not going to go through the process right now is because I want to put version information in. So we recently released our first non-beta build, and that has a particular version derived from the date and a hash. I don't commit these things to memory. It's somewhere in our docs to tell you what that version is. If I make changes to this and evolve these over time, that's fine, provided that we preserve backwards compatibility or forwards compatibility, right? Like I don't really like introducing stuff that is clearly going to break, or at least I don't want it to be surprising if something doesn't work out. So what I would like to be able to do here is show which version this connection meta parameter was added in, and then explain around that. Now in Wes Terms docs, I've got a kind of a nice since version macro thing that works in the documentation system. Now that's related to the documentation system here in KumoMTA, but there's a bit more like overhead to go through with that. I don't want to turn this into like Wes explains the whole world in a live stream, but that's kind of what I would like to do. So I'd like to sort of say like connection meta was added starting in our like nightly builds, and then be able to go back and sort of update the version number when we go to sort of cut the next like tag. And so the mechanism I have from Wes Terms docs would actually be really handy for this here. But essentially, if you ignore that overhead at the moment, essentially what I would do is add the parameter to the list at the top, and then in a paragraph down here I'd explain, hey, we also have this connection metadata, and then maybe I'd write another page that sort of describes what the connection metadata is, and then we'd have like the sort of handful, I think it's about 5 different callbacks go reference that, so that it's not a lot of repetition on each individual page, but also like, and then we can centralize some examples showing like how that state is sort of shared between the two. So I won't actually update the docs here, but that's my plan. I have shared my plan. But what I will do is, we should run the tests. I don't think this breaks anything, but let's just run the tests. Well, assuming this passes, which I think it will, I'm going to commit this and push it. and then I'll wrap up the live stream. But let's just see if it passes. Yes, it's a very pregnant pause while we wait for it to build. So much action. Here we go, tests are running. Good, it all passed. Great. Well, really, that's it. I'm not gonna. I will commit this in a moment. I don't want to do it on screen in case something happens with like typing in the password and so on. I will just hit that off by not doing it. But I will do that in a moment. I'm going to wrap this up. Thank you for watching, and I hope to see you next time I do one of these things. Thanks.